Good morning and welcome to today's webinar. Glad you could join me. What we're going to do today, as promised, is start working on a repavement project and use Civil 3D tools to do it. And we're going to employ what we call the Jump platform. My name is Chen Shum, and there's an email address. And couple of things that you're going to see, and you're going to see bits and parts and pieces of all of these. We have a seat product called Instant On Basic. It provides simply ridiculous, easy to use productivity inside Civil 3D. On top of that, we offer this collection of like now 5,000 styles, right? All standardized, documented, and all that kind of stuff, so that you can tweak your templates, including your own Instant On, to produce an effective production environment. For those of you who already got most of your stuff done but want to be NCS compliant and do .gov work, we have this idea of a symbol set. All the standard symbology from LDT and the NCS, right, in a little bit of package. And because we all don't work in Civil 3D, all the parts of our organization don't do that, we also offer a blocks only copy of that, so that even map people, AutoCAD, LT people, even in older releases, can use it. The concept that we're going to see today is extremely simple and extremely powerful. Instant On Basic simply allows you to work the same and intelligently publish on demand. We like to joke around that makes IOB an iPod, I guess. But the key issues here are that working the same and publishing on demand are really two different things. I had a chat this week with somebody from a really big organization, huge. You know, they are. I'm not going to name them on the air. And they said, we're dying here. We can't get consistent work out. And I said, what's the problem? You can use an Instant On Basic. Well, we're looking. But the key issue was they were trying to produce what they wanted to publish as what they wanted to use every single day to do their work, and not recognizing that because of the way CAD was, because of the way LDT worked, because we were stuck with stupid stuff, we had to work that way. The drawing you produced was actually the deliverable that you delivered. In Civil 3D, that's not true. That's the whole point. So anyway, our productivity here is based on a few core concepts. Employ national known standards, things like all the stuff we've had for LDT for years and years, and what the NCS is for whatever that's worth. And that's a whole bunch of intellectual capital that a lot of people spend a lot of time on, and use it as the path of least resistance to employ this incredibly powerful object-based piece of software that we all are now stuck with, almost, whether we like it or not. Key issues from our perspective is every time there's a new release, and there will be a new release, and there will be service packs, and our stuff is going to run each and every time. We've done that longer than anybody else, at more depth than anybody else in the marketplace. And all the parts, not just some of the parts, not just half the parts, but all the parts are in there. A complete structure is in there. The processes are in there. And lordy, it's all documented. You can get all that stuff for free. So we know that employing our products, our idea here, the concept behind them, are built into the simple way that Civil 3D was designed to work in the first place. So we make Civil 3D easier to implement and adopt. It has a return on investment measured in days, not months, not weeks, and really has a low cost of ownership. So it really comes down to a few pennies a day per seat, and you can go to work. So if you want to talk about that, always happy to talk. Here's 1-800-584-1506. Get sales at cadpilot.com. Always works if you want to get in touch with us. So we're here to talk about repaving and widening in Civil 3D. And quite frankly, this is like God's gift to show how cool Civil 3D is. It to do a simple repave and widening project in Civil 3D or in any other piece of software just about engages everything the tool does. So could we cover all that in an hour? Not gonna happen. But we're going to go over some core concepts, and we're going to walk through the basic steps and show you how that works in drawings and things you got to watch out for. And we're going to go back and work on some fundamentals that are necessary for the whole thing to actually hang together and work. So our goals here, right, is to understand that, hey, what you do at the very beginning in terms of survey, right, is critical. Survey in Civil 3D has exploded in its depth and ability in 2 releases. And if you haven't been paying attention, right, that means that if you were in 10 and now are looking at upgrading to 11 or 12 or wherever you are in the world, or going from LDT to Civil 3D, what's happened in survey, right, has made some things substantially easier for you to do stuff. Things aren't perfect. It's continuously developed software. It's always changing and getting better all the time. Every single surface pack makes things better, and sometimes, unfortunately, other things go away, as they do. So we're going to look at some of those things, and that's probably what we're going to focus on in terms of the how-to down at the end. There are a whole bunch of tools, as I said at the beginning of this presentation, that we need, right, to do a repavement job. But the key feature, and the key features for almost all the stuff we do, actually come down to a few simple things and a few really powerful features inside Civil 3D. One of them is obviously a surface, and that's what our survey stuff has a bunch to do with. Another are points that contribute to the surface, the horizontal control, and all of that. And we'll talk about that in quite a bit of detail. But the other key thing here is that horizontal control, alignments, vertical control, profiles, those 2 interlinked things that are really actually should be almost one feature, because they are one feature, but Civil 3D treats them slightly differently because we think of them slightly differently at this point in time, are key to getting this whole thing to work. Without good alignments, without good profiles, you're dead in the water to make this stuff work. And I want to point out that our old sloppy AutoCAD based, well, I'm just going to hack together a P-line between the points, works, and you can convert it into alignment. But you have a whole bunch less in problems controlling things and getting the iterative thing that we all need, the better QA thing we all need to get more design flexibility. Boss changes his mind and you did it one way, now you got to go back and start all over. Whereas if you employ things like the layout toolbar, design tools built into Civil 3D, makes things a lot easier. And we're going to take a look at Best Fit and how Best Fit, which came out in 11, got better in 12, right, can help you do some of that work. So the other key tools here, you need to understand the overlay of sub-assemblies, and I've done a number of sessions before, and you can just point you at that real simply. Webinars, recording page, bunch of stuff, and all the 11 stuff still applies to 12. So there's a repave here, another roadway reconstruction here that actually go through a couple, more than one, set of the overlay sub-assemblies and how they work and how you have to get there. So there's a couple of other, stuff. There's another repave in there, right? All those recordings help you and will help you make this all work for you in the real world. Okay? So understand the overlay assemblies, and I will say that if you've done a simple corridor before, all of a sudden the sub-assemblies got all kinds of weirdness in them. They connect to stuff and they connect upside down and backwards, and what you see on the screen is not what they appear. So you need to read the help file, and reading the help file is like, reading classic Greek. What the heck are they talking about? And so you have to read it more than once, and you have to read and play to understand what they do. There is no way around it. So are you going to need more than one rehab subassembly? In typical jobs, to be honest with you, you betcha. So you kind of have to go through a step-by-step approach, increasing the complexity of what you do. If you try to do it all at once and make the perfect rehab subassembly with conditionals and all that kind of stuff in there, you'll spend a whole bunch of time and may not end up with the result you want at all in the end. So adding curbs and sidewalks also says you have to understand this idea of a marked point. And if you can't do it in a regular roadway, you're really going to have a nightmare of a time making it work in a subassembly. So figure out, what marked points do and how to, hook them up. One thing we're going to cover next week is how medians work, and since medians are completely tied to mark point subassemblies, hey, maybe that might be something you would be interested in joining us next week. And then, of course, one of the primary reasons that we're doing this rehab is, and one of the critical things we need to find out is how much of everything are we going to need, and that requires that we have this thing called section groups and sections, and they also help us figure out if we've actually done the right thing. In other words, we need that vertical control. So we're going to really do a speed through few drawings here and do a couple of things to make that all work. Key concept, because we are dealing with a corridor, is there is always something kind of referred to as the edge of travel way. Now, it comes and you have different flavors and names in overlay assemblies, but we're essentially doing the same thing. Where are the edges of this thing? And this is a intersection picture I show all the time, and there are edges of traveled way at the curb returns here, but there is also an edge of traveled way where intersection roadway 1 meets roadway 2 and the grade changes, what we would classically call the flow line. And depending upon how the intersection was constructed and what you have to repave, you got to kind of keep this kind of picture in mind. And so one of the things you got to do is assess what really is going on in the surface, et cetera, out there. And so Civil 3D has got all the tools to do that. One of the things that make that work in Civil 3D is how decent or how well thought out and how deep is your style collection that you employ each and every day. So one of the things I would say is, hey, if you want to climb in and start looking at, the default Civil 3D one, you got, a few things, right? Point styles, those one I pick, about 20, and, we got more symbols than that in a quarter block in an urban environment. So what comes out of the box is not enough. Hasn't ever been enough, won't be enough, and Civil 3D and this Autodesk doesn't seem to want to solve that problem for everybody. Okay, we, however, think that's a problem that you're going to need to make the tool work. So we're going to start from the beginning here. We're going to go to the prospector, hooked up to a project. Very important concept in Civil 3D. This ability to share the data and other features back and forth between drawings is a critical idea and concept. And Civil 3D does it in a totally different way than we did it in the old LDT days, where we sort of had some data that was sort of shared in projects, though you could argue about how well that was done. In Civil 3D, this data transparency comes in a number of forms. One of them are data shortcuts, and we're going to employ them. We got templates, and here's the standard AutoCAD ones, and we're hooked up to a project. So hey, we got some IOB ones, and we're just gonna fire off a classic IOB design template. Now we hear on the street that, and we do sell templates, but there really is, in my opinion, no such thing as the perfect template. Because in fact, you're going to need different tools to do different kinds of things. So best you can get is something that gives you enough of the tools to do most of the projects you do, and then probably create some specialized ones. And we're going to review a few drawings here before we actually come back and go through a few step-by-step things that were done with a slightly tweaked version of IOB. So let's open a drawing, and we're going to start a little way down the road. And what we mean by that is we got a drawing, number of things going on. You'll see, hey, we get a couple errors when things light up in our drawing. We've got a selection of points, and they're the only points in our drawing. We also have in our drawing a surface, which is, I can see, a data reference service built by the survey guys. It actually, if I went and opened the drawing, you would find that it's actually hooked to an XML file. So pretty hard to edit. Okay, it produces the existing surface that they've certified, said, hey, this is what we found in the real world. And we also took some of their points. They came from somewhere, and we'll talk about how we got just those points looking just this way to deal with our problem. And we have, one small section of roadway here. If I turn things off, you can see this is the existing surface, and you can see that we actually, got a reasonably good representation of what the roadway looks like. And, it's Civil 3D, so hey, I really want to check stuff, right? Hop up to the object viewer. It's all a three-dimensional, real 3D thing, right? Okay, right, what's going on? And quite honestly, there are a few little funkinesses in here, right? And you'll see, hey, did my ditches all turn out right? Maybe yes, maybe no. They got what they got, and I got what they produced for me. But in any case, it's going to be enough for me to figure out how much pavement I need along this 1,000 feet of road or so. Okay, I got an alignment here that came from somewhere. And once again, maybe this came from record, etc. If you don't have that information, certainly what they go out and shoot in the field isn't exactly, what was designed, because what was designed isn't exactly what got built, and what got built certainly doesn't remain the same in any case. So, which is why, hey, we're gonna keep having to work. Good news. But anyway, so I have a reference alignment, okay, based on record stuff. Civil 3D is squealing and telling me, hey, according to record, these are two non-tangent curves, so Civil 3D immediately gives you some feedback about that. And because I need that alignment, and I'm going to need to have a corridor, because a corridor is going to do most of the work here. All corridors require an alignment profile pair, even if I'm not employing one of those parts, right, in my project. So this is an example when we're using an overlay assembly, which we have one here, and we'll climb into it in just a second, where we built the corridor, and we've got a quote-unquote design profile that at this point we're completely ignoring. Okay, so here's one of those subassembly weirdnesses. So what did I say? Okay, so we made a corridor, and currently, because I turn automatic off, because I don't want Civil 3D recomputing all my bits and pieces of corridor all the time, and you do that by making sure that's checked off. I need to do a rebuild, and hey, I will have way at the end, right, at the end of my corridor, I got a little hinky where it can't find something because my horizontal control is slightly off. Okay, so we could fix that at this point, not making any substantive difference, and you can actually see I couldn't find, there's no surface out here, right? Okay, and the corridor model actually shows me that. Now, why does it look this way? in Civil 3D, that's pure style. And we can get it at, quarter model, boink, and the jump's got a couple. How many of these do you need? Right? Here's the no plot one, so I can actually have it on my screen and see a picture of what it looks like. Notice it things changed. I'm not seeing the real boundary. I'm seeing slightly different things. This I can leave on my screen and actually plot, and it's not going to get in my way, but it may not be exactly the picture of what I want my corridor to be at the moment. So critical idea in Civil 3D is we got a bunch of data. Somehow wrap it up in here. Things are going on behind the scenes. We're changing those numbers and changing those parameters and changing all those properties. And we're probably going to need a number of pictures to define what it looks like. So we're just going to go back to the same place and put it back to our color corridor, right? Which actually tells me a bunch of information, design information about what's going on in my corridor. Have I changed? Where's the boundary sort of going to be? Where's the horizontal control? Where are the sections and the frequency of all that happening? Where I've actually adjusted things in view and edit section tools. So if I have, specific sections that I've tweaked, right, this style tells me that. So it's in effect a design style. And corridors have multiple styles, which is really befuddling and often very confusing. But okay, so let's take a look once again at the properties of our corridor. Parameters tab, key place. We got, that necessary alignment and profile pair, right? Both referencing data shortcutted data, right? That's coming from another drawing, so I don't step on it. I can't change it. I can't mess it up. Okay? And if you work with Bob in the next cubicle, you probably have experienced that problem. We're using an assembly, and it's called Repave, and we're applying it all the way down the street at an average frequency of 25, and we got some targets. And this particular subassembly requires only really one target, which is the existing ground. It doesn't require other targets unless we want to supply them. Critical, and we will later on down the project. So let's take a look at our subassembly. So we got the assembly. It's a container that may hold multiple ones of these. And in fact, if we were going to add curbs and all those sorts of things, we could. And if you've ever made an assembly, you understand that process, and we've certainly gone over it enough in previous webinars. Let's look at the properties of the subassembly itself at this point. And in all of the overlay, this is an overlay in mill. Okay, there are a couple of versions of it. As you can see, this happens to be the 11 version, right? Runs fine in 12. Okay, I can replace it with a 12 version, which doesn't appear to have any major changes, so I'll live with that. We have this idea of a code set style, okay? And this expresses in an immense amount of graphic detail how you would see things. Mostly we're just going for a couple of markers and those things in terms of what we see in plan view, right, on the screen. But the parameters themselves are the real driving engine of the subassemblies. And they say programmatically, what are we going to do and what are we looking at? Well, this overlay assembly is center-based. Okay, so it's running off some horizontal control from somewhere, and that always happens to be an alignment in Civil 3D or something that acts like an alignment. And so anything that has horizontal, right, horizontal definition to it, almost, right, as long as it's a Civil 3D feature. But in this case, since we're applying it to our corridor, in this case, our center, our horizontal control has to be defined by alignment. So, but not really, because we could go off the crown. Okay, couple of key issues. Targeting. We're saying, hey, go out, look at the surface, and using that horizontal control that we established with our alignment, which came from somewhere, please just slap this thing in using a minimum clearance. That's this value right here, right? And I'm going to put exactly the same amount of pavement on top, right? And while you're at it, kind of match the slope of where you found something at -2%. And, you know, if things exceed 0.5%, right, do something else. We'll find out what that is. And then please go and sample 10 feet to the right, 10 feet to the left, and please end the thing on about 16 feet away. And that resolves in our corridor when it's applied to this exact picture. So, hey, what's really going on in 3D? We got the new 12 section editor. Immediately, I get a picture of what things look like. Maybe I don't like the picture, and I could edit my command settings and say, okay, right here we happen to be employing one of the mysteries of Civil 3D, a code set style, which generates some labels and a picture of what our cross-section stuff is going to look like. And we can hop down the street here and, you know, go from section to section, and you can see our current horizontal control is not quite aligned with what's going on. And down in my plan view, hopefully you can see it, you know, we get, you know, a little picture. I'm going to zoom in here, right? So I can zoom and pan, and as I change sections, dink, I get, you know, this wonderful little picture that says, hey, you're right here. That's what you're looking at. Okay, and here we're kind of crossing over the old curb and gutter here because the horizontal control's off a bit, and we're definitely short, and our thickness here, right, okay, is all just slapped on top of what's there. We're not pulling, right, into our, what was that value? Okay, the depth and the amount we're putting on top are exactly the same, so we're not milling anything at this point. Okay, so, and, you know, but we get a good picture, and hey, we can go to key sections and take a look, right? Hop down there, and, you know, that's another intersection, so we got some issues on that side, still off horizontally, but hey, at least I got a picture, can see what things are, how things are going, right? And I don't need the section editor, and, you know, it's 12, so hey, all my viewports go back and it will remember, so when I come back in and look at it a different way, right, I can fix that. Other key things, there are these funny little things, right, strewn down the street, and they happen to be exactly, pretty much, but not quite, as we can see, match where I'm taking sections. Okay, and this little beast is going to be necessary for my final output. So once I had an alignment, right, I went to the home tab. So it's something about alignment, right? And here's our alignment, and it's in its collections. We have sample line groups. In a sample line group, we're going to go take a look at its properties. There are other ways to get there via the ribbon and all kinds of other stuff. It too has a name and, you know, sample lines, and yes, you can edit them, and yes, we could change how wide our sample lines are and all that stuff. We've done that many times. Okay, these can be defined if you're really sneaky when you make them from offset alignments, so they can vary and do all kinds of cool things, particularly if you've got widenings. Those actually help. So if you got the eventual horizontal control to make those offset alignments and attach them, right, you can get sampled sections that reflect what you're going to end up building. My key point here is that, hey, we want to create that extraction tool, right, early on in the process, and we want to say, hey, what we're looking at right now, hey, we're just looking at the existing ground, right? Okay, and in the end, we're going to need some kind of material list, and I'm going to pick a method of calculating the volumes, right? And, well, what do those things mean? Well, hey, the handy help button helps a bit, right? And practice helps some more. But, we'll also, need to do a bunch of stuff here to get our eventual volumes out. So we're going to close this drawing. And the key issues in this drawing were, hey, I had to have a surface to start with. I had to have some horizontal control and vertical control, at least to establish and build the corridor. I had to construct the corridor. I had to get the assembly and subassembly in there and hook them all up, right, in the 1, 2, 3 that is how to build a corridor. And actually, I did it all with the simple corridor tool, right? And so we're going to say, no, we don't want to save anything there. And then we're going to hop just a little bit downhill, okay? A little bit farther downhill, right? And one of the next key things we're going to want to do is, even before we start worrying about some other more important things like adjusting all that horizontal control and the edges and all those things, right? Another thing we're going to need is a way to compare what our proposed and existing are going to be. And so this is an example of our corridor has changed a little bit, right? And we're going to select it on the screen and go at it through the ribbon. And, we can take a look at our corridor surfaces. And so we added a corridor surfaces, based on what was going on from the top surface, right? And notice, hey, we didn't apply the overhang correction. Should have done that. Little detail, right? And apply that. Okay, so we made ourselves a corridor surface. It's got tops. They're added as break lines. We're adjusting and making sure that we're paying attention to the top linking. And, we just did a standard boundary based on the outside of the corridor surface where the cross-section control ends up. And so we can say apply, say okay, and we end up with a surface. And we happen to be employing a style, okay, to that surface. And this is a very useful style and part of the jump and built in for very, very good reason, right? It is got some properties here, and we simply said, hey, generate for me a slope arrow analysis. We'll just use the default 8 range. As you can see, anything that's between about 1% and 2%, because that's what's going to be produced by this corridor based on sampling side to side and figuring stuff out, up to, hey, about a 4% break somewhere, right, is going to be applied. So the effectively, red's real flat, purple and blue, real steep. And so we can see that as we sample the surface, you remember this was, what was that? How far apart? And hey, we kind of have to sometimes go back and remember ourselves. We were sampling out 12 feet, right, on both sides, and we're ending our little adventure here at 16 feet on each side. So, hey, maybe I'd like to sample. What happens if I do it at, oops, better remember, lefts and rights, got to keep them straight. So we're just going to go 5 feet. So we're looking at the crown, right, which happens to be 0, and now we're changing things to, 6 feet away. Okay, so now our sample distance is smaller, which will actually change, right, what our surface ends up looking like. Right? And corridor says I'm out of date, please rebuild me, and things are not going to fundamentally change very much, right? And how would you know that? Well, because what I'm sampling against, which is this surface right here, right? And we're going to look at it in a different way, right? And, you know, maybe I just want to see it as triangles and points for a sec. Okay, and that helps me take a look at, hey, based on how the surface was constructed, I got a very fairly non-complex set of triangles being produced out of this surface. So, got a bunch of stuff gathered and put together, and however they put together the surface over in the survey department was pretty dang regular, right? And I could see where they actually shot, and so it's a pretty rigorous station and offset, and that tells me that what I'm going to get sampling 10 feet away from 5 feet away, right, is only going to have, very small variances, and probably only at intersections and that sort of stuff. And I can see that right away. So my sample distance probably not going to change too much, right? So my original value was okay, right? And hey, for right now, I'd like that surface to, just go away and don't bug me, right? Still there, right? But I don't want to see it anymore. Okay, so now step 2, got myself a surface container, which gives me reasonably good feedback of what I'm going to produce from overlay. And now I got some more tweaking downhill to do. Close. And so, our next little process, right? Next little step in the process is, hey, we got to validate a couple of other things here, right? And we've done some more work, not a lot, nothing real rocket science. Checking my time here. Oops, better move quick. Okay, and we've added, right, some new targets to our quarter. And remember, most of the work is going on inside our quarter. And what we have added here are a couple of targets. We've created a feature line to define the end of where we're applying, the edges of where we're applying our overlay and mill. Well, okay, so fairly simple. We took some more horizontal control and said, here's where you should end what you figured out by looking at the surface from the center point out 12 feet or so, and where you should end it. Right? Hopefully that makes a bit of sense, right? And did we change anything in our subassembly? Could have changed some things in the subassemblies too. But actually we'll find out, hey, no, back to 12, back to 16, all the rest of the stuff. Oh, okay, so we changed our minimum clearance here, right, to -2. So we drop down below, and our overlay depth is, a full ½ foot. Okay, so what is that going to result in? Well, let's, take a look at our quarter, and we're going to select the guy. Hey, we'll do a rebuild, make you feel happy. I know nothing will change, right? And I'm going to select that guy, and once again, hop into the section editor. And hey, my first section doesn't have anything because first section doesn't have anything applied. Another little adjustment I made to the corridor is, hey, ignore the first ones. We're not worrying about down there. That's a whole nother intersection that we'll deal with later. Our project goes from there up to a different spot. So, okay, and hey, now we have a different, do we have different look and feel here? Okay, so we have, our standard, this is a standard jump, right, overlay assembly, right? We'd like to do it with, an overlay version, okay? And that overlay version code set reflects things slightly differently. You'll see basically I've changed the color, made it easier to discern where the difference between the existing grade and the new proposed grade are clear. I could, of course, turn off my centerline pieces for the assembly and profiles that exist and are referenced, right, in my view. Okay, and we can hop around and you'll see, hey, I get a nicely resolving 2%, right? And even through my intersection, okay, you can see, based on that, feature lines that were actually constructed by grabbing nodes of points that we had in our first drawing. All right, I get a pretty nice match to overlay right to the flow line, all the way up and down the street. Okay, adding and cutting and producing, all right, the result I need. And I'm going to close out of the section editor. And we also, hey, produce for the boss a real simple sample section, right? Single one at 1525, show and validate for everybody, hey, what's going on? What are criteria? We could label more inside this section. We could produce pages of them, in fact. Because we have nice section view styles, and hey, if I want to change what the view style is applied, this is the jump, right? So we can apply a totally different look and feel, and get a different view of what the sections are, how the sections are banded. We can actually do volume table for it. Okay, all that built in, all that done simply, and we can see it any single section where we are, right? And got a good validation, good, quick and dirty out the door. Hey, this is what pretty much we're doing up and down the road. Okay, and all these little things help us immensely, and they are, of course, completely throwaway. I can delete. Go look at another section. Go look at a page of sections. I can go look at a range of sections and see what's going on as things happen. You will notice a couple of little things. We added these feature lines, right? And so there's the corridors, edges being defined and created by feature lines, right? A output product of the corridor itself are those, and there are actually other feature lines buried that are providing that control. And you can see that because we're using an overlay and using those edge targets, right, we start to get more sampling. And in fact, at any critical point, in other words, at any node that we picked to create our feature line, we will get those additional density of cross sections, applying our parameters into the corridor. So this is a reflection of how the corridor engine works, right? You want more, you add more control points. Civil 3D is immediately going to, connect the dots and give you more sections. So our other sections, if we wanted a particular section, right, and add another sample line at one of those sections, easy enough to add the additional sample lines. So we're through that process, right? And how about my sample line group? Did I make any changes in there yet? Okay, where was that? Center line alignments. There's the one I'm working on. And there's my sample line group. Okay, and I got my sample lines, and I got some sections, and let's look at its properties again. And so, hey, no material stuff done. If, hey, I want criteria, we can do, hey, give me a big long material list, right? Take the pavement material, and that's going to be the overlay and my sub-base material. Okay, so I got some material definitions here, right? I want to change, but hey, we'll just take that as the mill, right? And not connect up the base. But all the names, surfaces, and corridor shapes have been mapped. Do I want to know? Okay, and so I get a partial material list, and I want prismoidals, right? Apply, and see when I say okay, Civil 3D, well, grind out, and hey, give me some volume output, and then I need to somehow spew that out on the screen or in some form. Get that shown out. Okay, where in the heck was that? Well, it's A volume report. No, how about a total volume table? Maybe that'll work. Okay, well, pick this one, and we're looking at that sample line group. And yeah, we did make a serial list, and don't split my table, and just make it static because I really don't care, and spew it out, and hey, I get a volume report on my screen showing me nothing. So I still have some things to figure out here, right, about how that whole process all works. And maybe next time, let's go back where we started in the beginning and deal with a couple of other things in terms of Civil 3D. We started drawing, right? And one of the things we want to do is, make sure we're in the same coordinate system that all the rest of my project is. And now, one of the things I needed was a surface, and oops, better save this thing somewhere. And the jump comes with, this nice model-based feature-centric UDS, or Uniform Drawing Standard compliant folder structure that actually works sort of way Civil 3D is. And we're working on a roadway here. And I got some other drawings here. We're just going to call this one, and it's not going to be an intersection. We're just going to call it 51 just to give myself something else. And this is a repave, and maybe I want to throw in what my corridor is, okay, where I think my corridor alignment is, so I can identify what it is, and how you name that drawing is fairly important in terms of keeping things glued together. Putting it in the right place is probably even more important, right? And now I need, that survey data that the guy supplied. Here it is. We'll just create a reference to it. We'll take the default style, and go up here, and it does take me a little bit longer to zoom to by using the tool space, but one of the problems I got is the edge of my surface, which happens a lot when we're talking about repavement, because we only go back a walk and don't worry about what's going on in the yards, right? So very often you may be working on the edge of a surface, which is, a fascinating problem to have to deal with. Now I'm going to need to establish what that alignment was. And doing that, okay, so let's go back, and I need some stuff from the surveyors. And surveyors gave me a CSV file. And of course, I go home, import points, and blast them all in, right? But I'm a little smarter than that. I've been at this a bit. One of the things is I better make sure my settings for survey are set up to go and do what I want. Actually, that wasn't the right one. I want this one. Okay, and we just change some things in what we're pointing at, right? How figures are built and all kinds of stuff all at once. So one of the things about survey is it's got this own self-contained profile generator, which is worth learning about. And I got some survey databases, which, got a folder location, so I'm pointing somewhere inside my project. It's not necessarily the root of my project, like my data shortcuts point. And I got myself, right, a survey database that I already built from what the survey guys handed out publicly. And notice, interestingly enough, this happens to be, right, a CSV file. And from that CSV file, and there's exactly where it is, and it tells me where it is and where it came from and what day I got it and put it in and what kind of format it is, all kinds of cool stuff that help me go, oh yeah, that's where it came from. I remember that stuff. Okay, and it generated a CSV file, generated some figures, right? Amazing. Right, so we actually managed to get some figures generated, and I'm going to drag my tool space out. You can hold the control key, by the way, to do this, right? Drag it out there. And, when I'm starting to deal with survey stuff, it's really nice to kind of have a couple of different lists here. And I got some figures, and, I sort of know what the survey guys use, and I'm looking for centerline stuff here. And so where's this guy? Okay, and that's not the figure I want. Wait a minute, maybe that's the one I want. Hey, that's one of the ones I want. Okay, so I need the points from that, and I've played around a little bit, but here's this really cool thing. I can say, since survey is based on points, right? Oh yeah, I can insert the points from that figure into my current drawing. Oh, okay, that was kind of cool. And hey, one of those happens to be a traverse point. That's pretty cool. Okay, what's this little piece here? Where's that guy? I can double click and I'll zoom you to. Well, no, that's somewhere way the heck and gone, right? How about this one? Oh, hey, there's, a big long piece, right? I need that one too. And how did I do that? Right click. So is my friend here, and insert those points into my drawing. Okay, and I happen to know I'm looking at this and I'm going, there's a connection to another point figure, and we can zoom to that guy too, right? And you'll see that connects another piece of connecting the dots. So I need those couple of points and put those into my drawing. And let's redraw my tool space. And now I just got a very selected set of points into my drawing based on centers. I happen to also bet there's some boundary stuff in here, and we can sort by, well, there's stuff in the street. Let's sort by my description. So I got some boundary points in here. It would be kind of handy to see about what point ranges things are at. Okay, so let's do a little work in our point groups and what's going on and how things are displayed. First thing, you're manually, okay. Update makes all those points that I just brought in go away. Where the heck did the points go? Well, they're still here. Oh yeah, that's right. Point groups, they control what things are, that point group property. I want everything to look the same. Please put that at the top of my pile. Go to my all points group for a short period of time. Yeah, point style standard. Who thought of that name? I want something that zooms and pans and is relative to my screen, and that's my viewpoint. And hey, let's make them a little bit bigger for now. Right, hit apply and say okay, and I just broke one of the major rules, right? Inside Civil 3D, according to everybody on the planet. Oh, hey, wait a minute. But that's a style I know people are going to mess with, okay? Because we've agreed you can mess with it. And if I zoom way in, my little X's, right, are going to get smaller. And if I zoom way out, my little X's are going to get bigger. So I got a lot of control, and I can adjust it, and everybody knows I can play with that one. Okay, so I wanted those things. Now I see them. What was I doing? Oh yeah. Okay, back into. Okay. Oh, and what I needed was I need some labels on there, right? And jobs got tons. This is IOP, Okay, what do we want? How about raw and point number? That will help. Okay, and we slap those on everything. So now I could see, okay, what actually the surveyor handed over to me and a point number. So, I'm kind of looking for a range of 7127 to 3050. And so, wait, there's one, right? And, let's, pump that baby into the drawing. Hey, there's a boundary on the street. Okay, that's probably going to be on my alignment. I can always, zoom to that one. Oop, Okay, let's back up a little bit. Hey, there's another one, right? Put that into the drawing. Okay, and how about this one? Pan to that one. Okay, that's somewhere off in Neverland. Pan to that one. How about earlier ones? Pan to that one. Okay, but looks like those are maybe 27. Pan to that one. No, pan to that one. Actually doesn't take me all that far long to go through the BDs, right? And see that, hey, those are the only two boundary points, right? That I found. Maybe add another setup point or something else. There's a setup point there. Might have a couple of other setup points, but that's pretty much what I got to work with to generate for me an alignment. And I did all that because I'm so smart, and I know that I can go to the Home tab, I can go to the alignment, and I can create a best fit alignment. And what I can do is look for Cogo points, and these best fit tools. Look carefully at the list and what's available to you, right? Okay. Cogo points would make sense, by the way, to have alignments. Point groups. Notice I could build my centerline alignment from flow line points. If that's all I got and they didn't shoot ground points, all they showed was flow lines or something, I can actually use 2 to generate this, right? Happen to know it's a local street. We never use profiles. Maybe it's pretty far out there, so maybe I better make that 5,000 feet for the minimum radius, right? We'll give it a name, but I can rename that and should take care to rename it later. I really don't care about what it's labeled. Please, no labels, no labels. Wish that was an alphabetical list. I could throw it to any NCS layer in my drawing that I want, right? We don't really care because we can fix that later. Okay, so we're using Cogo points that we brought into our drawing that happen to be in a point group. Okay, hence why I made my little point group. Also why I made all points the top of my stack, so I didn't have to do any work, right? And we're going to create an alignment, and we're going to use our design layout style, which is going to show me the curves and all that stuff, and say okay. And I'm also leaving, very importantly, this little show report box. Not that it will let me change anything, so I'm going to say okay, and it's going to actually resolve and build me something. Couple of interesting things. You could ignore this, but how divergent things are and where they diverge, right? So I got one point here, yanking stuff off, right? A mile. And, we could sort this list. So, hey, show me. Okay. And so the first 0 through 4 points, right, are the most divergent points in my entire alignment. Worth paying attention to. Everything else is staying near right on the curve, right? Okay. And as you can see, right, it generated a single one gigantic long curve, right? And got that fact. Okay, let's go to the geometry editor, see what we ended up with. Oh, okay, so we actually got a teeny little line. Okay, and a teeny little line. All right, teeny little lines in one gigantically long curve, right? And notice if I left my stuff smaller, saying 3,000 foot radius, I would have gotten a completely different result. Well, let's test that out. Is that really true? Okay, so undo. I zoomed all. Let's get rid of that best fit thing. Okay, and go back and try that best fit alignment tool again, and we'll leave it there. Okay, and we'll leave it at our 3,300, and we were looking for Cogo points, all points, and I just wanted to get rid of that. Why isn't this not in alphabetical order? Okay, and say, okay. And now I get a different regression graph. Let's see where the worst stuff's at. You know, still my worst stuff, but hey, I got a much closer result. I'm not like 8 feet off here. Okay, I'm like 4 feet off. Okay, hey, that's much nicer, right? Whatever that result was. And I ended up with a couple of curves, right? Okay, got a curve here, a tangent here, a curve here, right? And stuff there. And, you know, I can check with my geometry editor and my best fit result, which I now, having done this a bunch of times, we'll drag the panorama down here. We can actually dock and park this guy, you know, if you want, dink down by your command line, which can be pretty handy. And, you know, you can't zoom to like we could that nice figure thing, but, you know, it'll at least show you where you're at, right? You pick one of those, that's the one. Okay, and we got a little bitty tangent. It's going in the right direction too. So one of the things, right, that they kind of hide away. Maybe, you know, we want to go in the other direction, right? So hey, we should show you where that was. Maybe I want it to go in the other direction. Best to do this early, right? And flip it around. Okay, and here I got labels, and you will see it all relabeled and ran back the other way. Well, I'd like to flip it back around the other side. And this warning is just telling us that every time you do a flip, it breaks all the other stuff that might have been in the alignment, which is a connection linearly down. Okay. Okay, so, you know, we got our best fit, right? Things look like they're running through the curves, right? But we probably need to make some adjustments here and do some alignment editing and, right? Do we really want that little teeny tangent? How long was that thing anyway? Let's see, right? Okay. Okay, so, you know, hey, we got, hey, how about if we make that 2380, you know? Okay. Oh, I can't solve that. Okay, it's constrained on both sides. Oh, that's why. Okay. Okay, so we got a little line. And actually, we're looking at the line at the end here. Got this little line. And go down. You got this little line here. Okay. And we can, it's 12. So I can constrain it by the previous one, right? And, you know, get that little guy, and maybe, you know, I'd like to get rid of that little piece. I don't want that little guy in my alignment. Okay, but I do kind of want to make sure that this little piece is hooked up to, hey, what was that? A node, the node of that point, right? Okay, and Civil 3D will immediately, you know, fill it back to me, right? It's about everything else I want to adjust and can adjust in here. Take a look. My tangent's probably off a little bit, but hey, you know, this is just survey-based stuff, right? But, you know, I'm betting the end of this curve here is really at the node of that boundary point. Okay, so, okay, that gives me, that's sort of a radius, right? And pretty good. And, you know, maybe if I massage this to something design-wise, right? Okay, and, you know, a little bigger. Okay, it's actually a little smaller, so hey, how about, hey, let's be really gross and just say it was 2,100 feet. Okay, yeah, probably could get smaller than that. And I can, you know, play until I am happy that my values are something reasonable. And appropriate to the geometry I at least got. And once again, I'm making a best human guess. And yeah, we're drifting over here. So, probably once again, oh, that's at the beginning, right? So what happens? Well, let's save those changes. And how about if I grab that guy, go to the geometry editor, what happens if I yank off just that first tangent? Say the heck with that, right? And drag my point right down in here. Okay. And once again, I probably got some adjustments to make, but you get the process, and I can get a pretty good approximation of what it looks like. Now, I also need, oh, gee, I need a profile. If I want to build that corridor that I was seeking, I need a profile. Okay, and let's just, create a surface profile based on the current state of that alignment, which I can always fix up and do that and slap me a profile view. And, it's a jump. We got tons of things to do. Let's just, fill in. Yeah, let's just do a 3x just to be interesting. Create a profile view. That's out of the jump kit. And I get my profile, get a whole bunch of labels. And just, gotta work in those command settings, Put a label set, just do that one. Oh, I think I want a real simple one, right? That's my existing ground, apply it there, right? And, I get slopes, and hey, that dang near looks like, and it should, right? One basic, one really, really, really basic, really, really, really simple line. Right, this is going to be my design, and of course I can, do create design, right, create profile and draw it manually, but I can also use a best fit here, okay, and, we want to grab it from, oops, missed, and we'll do a best fit profile, grab this, and we are looking for a surface profile, and from surface, and I can weed stuff out, and teeny little angular tolerance, that's probably ridiculous, right? Okay, so weed out anything that varies by hundredth, right? Maximum radius, 33,000, fairly big. I can actually do circular arc curves. I happen to know it's that. Design profile, give it a name, go to a layer, okay, but it'll do all that stuff, processes my whole stuff once again. I'm looking at how much did things diverge? Not much, right? Okay, and got a few variances here, right? But they're nearly zero because it's going to end up being, right, a singular. Yep, there's my design profile, right? Let's throw some labels on there just so I can see what's going on. We got label sets, and do a layout one, right? And we'll throw all the stuff on here. We can always thin this down later, right? Okay, and so, hey, it actually threw in some itsy bitsy teeny weeny vertical curves here and there, right? Okay. So that allows me to see what it did without rooting around too much. Some of them are probably fairly ridiculous, right? But it did get me a solution to a profile, right? And given the amount of time we got left, which is none, right? Let's hop back over into PowerPoint, right? And find out what else should we do, right? So here's a basic step by step of what corridor reconstruction is all about. You're going to need a corridor to produce the overlay for the roadway. So you're going to need a baseline alignment and its offsets, right? And if you employ the edge-based subassembly, remember that the connection point is not the same as the center point one that we did. Then you're going to have to create that subassembly, right? Configure the subassemblies, connect all those corridor parts, we're going to need the alignment, and we'll probably need offset alignments, right? Okay, so I've got in my current drawing, you saw back there, hey, I got my alignment. I now got a profile. I'm not even going to employ that profile to do anything other than create my corridor. So I could have just drawn a tangent, for example, right, and modify things later. However, I do want to make a little point here before I leave, is that this roadway actually may have super elevation applied to it. Okay, and depending upon the speed of the roadway and how it's signaged and etc., we may have to actually repave with a lane. Okay, and that is indeed completely possible and able to be accomplished inside Civil 3D without trouble. Okay, and then we're going to need to tweak some targets. We're going to need some offset control, right? The surface in almost all the overlays is going to be a critical target, right? Or you can also do alignments, both offset and center line ones, and profiles. So we may have to tweak, our edges to deal with what's going on in intersections, etc. And you need to create those corridor surfaces so you can evaluate the end product result. Is it producing what you want and meeting your criteria? Okay. You're also going to need, as I said, those sample line groups, because they're going to do most of the output work. And we sort of got there, but not quite, but we at least got close, right? It looked like our material list had some issues, or we missed some little critical step there, right? But certainly to produce the material list, to do a quantity takeoff, we're going to need that material list and figure out what we got wrong over there. Probably you're also going to want profiles and section views, and view and edit sections is a really good way to validate that you're actually accomplishing what you think, right? Single section views validate for others, produced as drifts or pages of sections, or as singles at critical points to validate that you are actually making good design decisions. And then there's a whole set of, given you have this corridor, and we saw you the quick report, and that validated that we didn't quite get our material list stuff done right. We dumped it in a table, and there are also, stuff in the report engine by XML. So get yourself a copy of Instant On Basic. Hey, without the ability to visualize what's going on in a way that makes sense, Civil 3D is much, much harder to learn and much, much harder to get productive work out the door with. So want to